In the vast expanse of space, strange planets exist that even science fiction couldn't have imagined. For the first time, scientists are uncovering extraterrestrial worlds beyond our solar system. Places where ice is scorching and iron rain falls. These uncharted, otherworldly places defy predictability. And hidden among these peculiar new worlds, researchers seek the ultimate discoveries. Planets similar to our own, alien Earths. On March 6, 2009, a Delta II rocket undergoes its final pre-flight inspection. The launch marks the start of an exceptionally ambitious mission. Liftoff begins an observatory search for Earth-like planets within a region of 100,000 stars. This is the climax of the journey that started more than a decade ago with one of the most remarkable scientific discoveries ever made. In 1995, Swiss astronomer Michel Mayor and his team observed stars in the Pegasus constellation located 50 light-years away. The data revealed something odd. One star's violent wobbling movements. What could be powerful enough to disturb a star the size of our Sun? Mayor proposed a groundbreaking explanation: a planet. But no one had ever observed a planet orbiting another Sun-like star. Detecting planets around other stars is challenging due to the overwhelming glare of the nearby star. Despite the odds, Mayor trusted his data and believed the wobbles resulted from the gravitational pull of an orbiting planet. Initially skeptical, other scientists soon confirmed Mayor's findings, making a groundbreaking announcement that rocked the scientific community. They had discovered the first ever evidence of a planet orbiting a Sun-like star, 51 Pegasus b, nicknamed Bellerophon after the Greek hero. Bellerophon is a planet that defies expectations, with temperatures reaching roughly 1,800 degrees Fahrenheit. Nearly 150 times Earth's mass, it is a gas giant similar to Jupiter. This unprecedented find introduced an entirely new class of planet: hot Jupiters. Hot Jupiters orbit their stars approximately 100 times closer than Earth orbits the Sun, receiving 10,000 times more sunlight. These planets are tidally locked, meaning one side always faces their star. Temperature differences create extreme winds with speeds reaching thousands of miles per hour. Water vapor cannot exist due to the intense heat, but iron vapor can. Rain on these planets consists of iron droplets, making for a truly alien landscape. Charged particles from the nearby star create vibrant auroras far more intense than Earth's northern lights. Bellerophon's tiny 4.2-day orbit around its Sun challenges long-held beliefs about planet formation, leading to the realization that planets can migrate inwards. Planets form as a byproduct of star formation, with leftover dust and debris eventually sticking together and growing into larger celestial bodies. Observations from the Hubble Space Telescope have been crucial in understanding this process. Over time, planets migrate through the disk until they find a stable orbit. This is why Bellerophon is so close to its parent star. However, another newly discovered world has found its stable orbit in a place where no planet should ever be. In 2001, the Hubble Space Telescope focused on an inconspicuous star about 150 light-years away from Earth in the Pegasus constellation, the same region where Bellerophon was discovered 6 years earlier. Hubble tracked another hot Jupiter discovered by astronomer Jeff Mossey, but this one was different from Bellerophon. This planet, named HD 209,458b, has a harsh moniker that reflects its inhospitable conditions. Some have dubbed it Osiris after the Egyptian god of the dead. Osiris is over 200 times more massive than Earth, making it an extreme and dangerous place. The planet's close proximity to its star causes it to experience scorching temperatures and intense radiation, creating an environment where only the most resilient or alien life forms could survive. As more exoplanets continue to be discovered, scientists are broadening their understanding of the diverse range of planets that exist beyond our solar system. These strange new worlds, from hot Jupiters to potentially habitable Earth-like planets, are reshaping our understanding of the universe and inspiring us to search even deeper into the cosmos for the unknown. The average daily temperature on Osiris exceeds 2,000 degrees. Forget global warming. This is global frying. It causes Osiris to lose an estimated 550,000 tons of air every second. There's a leak of gas, a steady stream of hydrogen and helium, which creates a huge cloud all around the planet. Its atmosphere is bleeding into space. Scientists speculate that a colossal trail of gas spirals behind the planet for thousands of miles. Osiris presents an unprecedented opportunity for astronomers. Using Hubble, they analyzed the alien planet's bloated atmosphere. This is the first time we could determine the composition of the atmosphere of an extrasolar planet. Surprisingly, Hubble detects many of the basic chemicals needed for life: sodium, carbon, hydrogen, and oxygen. However, Osiris is far too hot for life as we know it. There may be other forms of life that thrive on higher temperatures, but there's no solid surface, as we know it, on a hot Jupiter. So, any life there would have to be tiny microbes floating around on aerosols. On our own Earth, we have life that floats around in our atmosphere, but that life didn't start there. Consequently, life almost certainly would not exist on hot Jupiters. Astronomers have discovered many hot Jupiters since Bellerophon was found in 1995, but conditions on these worlds rule them out as places where the drama of life can unfold. One of these gas giants is a planet that defies the rules of evolution. Astronomer Jeff Mossey discovers something shocking about a planet orbiting a star called 16 Cygni b, located some 70 light-years away in the constellation of Cygnus the Swan. The planet has an elongated orbit, bringing it close to its host star and then far from it, defying our expectations based on our own solar system. Here, all of the planets have nearly circular orbits, akin to phonograph grooves in a record. This gas giant, reminiscent of a giant yo-yo in space, swings back and forth across its solar system. It's as if Earth were to swoop 25 million miles closer to the Sun, then swing past Mars all the way out towards Jupiter every year. Like all of the gas giants in our solar system, this yo-yo planet might have an entourage of moons. Mossey speculates that one of these moons could be similar to Earth, and that's where the fascinating story begins. Imagine a rocky moon with lakes, oceans, and possibly even streams and waterfalls on the surface. This moon orbits its planet, with both of them circling the host star. Unlike the airless moon that orbits Earth, this moon is a world with extreme seasons. On Earth, seasons result from our planet's tilt. However, on this moon, the elongated orbit causes the seasons. Planets in these elongated, elliptical orbits experience dramatic changes in their climate throughout the year. As they make their closest approach, the yo-yo planet and its moon are bombarded by the star's intense heat, signaling the start of summer. The atmosphere on the Earth-like moon is then ravaged by raging storms. Category 5 hurricanes on Earth would seem like tiny eddies when compared to the monstrous vortexes that form here. As the water evaporates, the clouds thicken, leading to a sharp rise in temperatures. Water and other gases heat up to such an extent that the oceans could boil into steam, turning the moon's environment into a vast steam bath. Here's the corrected and punctuated text. During the peak of summer, the entire moon is smothered in 800-degree temperatures. This is the closest approach to the star during its 26-month orbit. The summer season is barely 2 months long. What a season! The planet and its moons swing away from the furnace of the star. Temperatures fall to ranges we would find temperate and comfortable. With the coming of fall, the rains return to the parched and roasted moon. Dry ocean basins are replenished, and the seas rise to form new shorelines. Tranquility prevails as the yo-yo planet and its moons slip into the deep freeze of winter, now over 200 million miles from the star. The daytime sky is dark, and temperatures hover around 260 degrees below. Winters are long, lasting 17 months. With the coming of spring, the sun looms large in the skies over this hapless moon as the ice cracks and melts violently into a stormy and fast-rising ocean. For 2 precious periods during the spring and in the autumn rains, The climate on this Earth-like moon is balmy and comfortable. At a distance of 93 million miles from the star, roughly the same distance as Earth from the Sun, the elliptical orbit of this planet and its moon crosses an area around the star some scientists call the Goldilocks zone. Conditions here are just right for life. If you're too close to the star, then it's too hot. If you're too far away, then it's going to be too cold and everything's going to be icy. But if you're right in the middle, it's just right. Every star has a Goldilocks zone. Where that zone is depends on the size and temperature of the star. In our solar system, Venus marks the inner boundary and Mars the outer boundary. Earth, with its abundance of life, lies right in the middle. The yo-yo planet passes through the Goldilocks zone twice a year. For 3.5 months during the spring as it races inbound, and again in the fall for 3.5 months as it hurtles back into the colder reaches of space. Could life survive the conditions outside the Goldilocks zone? There could be life forms that are smart enough to hibernate, as animals do on Earth during the winter season. If this sounds fantastic, consider the tidal zones on Earth. In the tidal zones, life proliferates near the seashore despite tides, with water coming in covering many of the life forms, and water going out at low tide. Yet those species survive perfectly well. The strange cycle of the yo-yo planet's orbit creates fleeting conditions suitable for life, but also for death. The ever-changing conditions on this yo-yo planet and its Earth-like moon present a unique challenge for life to adapt and evolve. During the brief periods within the Goldilocks zone when temperatures are more hospitable, life could flourish, taking advantage of the favorable conditions. Organisms would need to adapt quickly to the dramatic changes in temperature, climate, and available resources as the planet and its moon move in and out of this habitable zone. It is possible that extremophiles, organisms that thrive in extreme environments, could develop on this moon, allowing them to withstand both scorching heat and frigid cold. These extremophiles could employ unique survival strategies, such as rapid reproduction during the short windows of favorable conditions, or dormancy during the more extreme periods. Life on this Earth-like moon would also need to adapt to the volatile seasons and weather patterns. Organisms might develop specialized structures or behaviors to protect themselves from extreme cold and storms. For instance, some plants could evolve heat-resistant seeds that lie dormant during the hot season and germinate during cooler periods. Animals might develop hibernation-like strategies to survive the harsh conditions. In conclusion, life on this yo-yo planet's Earth-like moon would face numerous challenges due to the unpredictable and extreme environment. However, it is not impossible that life could find a way to adapt and thrive even under these demanding conditions. The discovery of such life would undoubtedly expand our understanding of what it means to be habitable and reshape our search for life in the universe. The possibility of life on this yo-yo planet's Earth-like moon raises intriguing questions about the resilience and adaptability of life forms in the cosmos. While the environmental conditions on this moon may seem inhospitable to life as we know it, the existence of extremophiles on Earth suggests that life can find a way to thrive under seemingly insurmountable odds. One factor that could facilitate the development of life on this moon is the presence of subsurface water or geothermal activity. These features could provide stable environments where life could evolve and persist even during extreme temperature fluctuations on the surface. Moreover, the presence of a protective atmosphere on this Earth-like moon could further enhance the chances of life emerging and adapting to the volatile conditions. An atmosphere could provide some insulation from temperature extremes and contribute to the formation of weather patterns that could help distribute water and other resources across the moon's surface. Additionally, the cyclic nature of the yo-yo planet's orbit could lead to the emergence of unique ecosystems that take advantage of the transient periods of habitability. Species could evolve in such a way that they form symbiotic relationships, allowing them to support one another during the harsher periods of the orbit. It is also possible that the dramatic environmental fluctuations could drive rapid evolutionary processes, enabling life forms to adapt to the challenging conditions at an accelerated pace. This rapid evolution might result in a diverse array of species uniquely suited to the extreme environment. The potential discovery of life on such a moon would have significant implications for our understanding of habitability and the likelihood of finding life elsewhere in the universe. It would challenge our assumptions about the types of environments that can support life and could lead to a broader exploration of planets and moons with similarly extreme conditions. Furthermore, the study of these hypothetical life forms could provide valuable insights into the resilience and adaptability of life in general. This knowledge could help us better understand the limits of life on Earth and inspire novel solutions to challenges we face in our own changing environment. Overall, the existence of life on this yo-yo planet's Earth-like moon would represent a remarkable testament to the tenacity and adaptability of life in the universe. While the environmental challenges presented by such a world are undoubtedly daunting, the potential for life to adapt and persist in the face of adversity should not be underestimated. Thank you.